আসসালামু আলাইকুম এভরিওয়ান। সবাই কি আমাকে শুনতে পাচ্ছে? পেজে একটা চ্যাট বক্স থাকার কথা, ওইখানে সবাই লিখলে আমি দেখতে পাবো। ওকে, আমি চ্যাটটা Okay, yes. Okay, I can see your writings. Okay. Audio, video, সব clear? ওকে, আমরা তাহলে 5 মিনিট ওয়েট করি, যদি অন্য কেউ আমাদের জয়েন করে। আমি 8 জনকে দেখতে পাচ্ছি এই মুহূর্তে আছে, যেহেতু টেকনিক্যাল সমস্যা ছিল। আমি মক ট্রাই করছি আগে, কিন্তু অ্যাজ ইউজুয়াল লাইভের সময় কোনো কিছুই কাজ করে না। Anytime any of you guys have any questions, you can write on the chat box. I'm keeping track of it here. যারা যারা দেখতেছে সবাই সবাই যদি একটু চ্যাট বক্সে লেখে তাহলে আমার জন্য ভালো হয়। Just say hello to everyone. ওকে, মানুষজন অনেক কম, সো যারা আসছে তাদের জন্য ভালো। সবাই যত কোশ্চেন আছে সব করতে পারবে। আমরা 3 মিনিট পরে শুরু করবো। 2 মিনিট। ওকে, আমরা মনে হয় শুরু করতে পারি। প্রথমে আমি অ্যাজ ইউজুয়াল কিছু স্লাইড বানাইছি। স্লাইড দেখা যদিও বোরিং, আই হোপ এটা বোরিং হবে না, কারণ আমার স্লাইডে শুধু ইমেজ থাকবে, নো টেক্সট। আমি স্লাইডগুলোর উপর দিয়ে একটু ওভারভিউ করে যাব, এরপরে অ্যাট দি এন্ড তোমাদের যত কোশ্চেন আছে ইনশাআল্লাহ সেগুলো যতটুকু পারা যায় অ্যান্সার করার চেষ্টা করবো। আর অ্যাট দেম যখন আমি বলতেছি স্লাইডগুলোর উপর দিয়ে, if you guys have any question at any time, you can write it on the chat box. আমি এখানে খেয়াল রাখতেছি, তো আমি সাথে সাথেই অ্যান্সার করে দেওয়ার চেষ্টা করব। ওকে, সো স্লাইডগুলো কভার করতে যতক্ষণ লাগে, দেন question answer session, extra question answer session. Okay, screen share. স্লাইডগুলো শেয়ার করতেছি। Okay, I have lost them. Oops. Just a moment, be patient with me. সবাই কি দেখতে পাচ্ছে এখন স্লাইডগুলো? সবাই কি দেখতে পাচ্ছে স্লাইডগুলো এবং আমার কথা শুনতে পাচ্ছে চ্যাট বক্সে? Okay, great. So, how to get into machine learning, deep learning? আমি অ্যাজিউম করে নিচ্ছি কেউ এই ফিল্ড সম্পর্কে কারো কোনো কিছু ধারণা নেই। So, if you know very much about it, please be patient with me. Okay. So, what is machine learning? Basically, machine learning হচ্ছে you have data set, you want to learn from that data set and to predict in the future. So anytime you have a data set and you have a problem where you need to predict something, that's why machine learning comes in. Machine learning termটা আসলে kind of বলা যায় কম্পিউটার সায়েন্সই, because machine learning দুইভাবে অ্যাপ্রোচ করে আমার ওপিনিয়ন অনুযায়ী। কম্পিউটার সায়েন্স পার্সপেক্টিভ থেকে, একটা হলো স্ট্যাটিস্টিক্স পার্সপেক্টিভ থেকে, যেটাকে স্ট্যাটিস্টিশিয়ানরা বলে স্ট্যাটিস্টিক্যাল লার্নিং। সো আমরা যেটা বলতেছি এটা হলো মেশিন লার্নিং, এটা হলো কাইন্ড অফ লাইক মোর কম্পিউটার সায়েন্সি, মোর এম্পেরিক্যাল, মোর এক্সপেরিমেন্ট বেসড। স্ট্যাটিস্টিশিয়ানরা মোর জোর দেয় থিওরিটিক্যাল বা ম্যাথমেটিক্যাল অ্যাসপেক্টের দিকে। বাট যাই হোক, দুই দিক থেকে অ্যাপ্রোচ করা যায় জিনিসটা। সো অ্যাট দি এন্ড গোল ইজ দ্য সেম, try to predict accurately on future events. So for example, আচ্ছা, এক্সাম্পলে যাওয়ার আগে আমরা আরেকটু দেখাই নিই যে জিনিসটা কি। সো ইউ হ্যাভ ট্রেনিং ডেটা, লটস অফ ট্রেনিং ডেটা, you have তোমার the machine learning algorithm, you put your data through their algorithm and you generate a classifier. Now তোমার কাছে ফিউচারে যখন নিউ ডেটা আসতেছে, তখন সেই নিউ ডেটা সেই ক্লাসিফায়ারের ভিতর দিয়ে তুমি ইনপুট দিচ্ছ। তো ক্লাসিফায়ার তোমাকে প্রেডিকশন হিসেবে তোমার তোমার প্রেডিকশন দিচ্ছে। যেই প্রেডিকশন গুলা ডিপেন্ড অন ইয়োর অ্যালগোরিদম কোয়ালিটি অ্যান্ড ডেটা কোয়ালিটি, ভালো হইতে পারে, খারাপও হইতে পারে। সেই ভালো খারাপটাই আর কি ডিপেন্ড করে হাউ গুড ইউ আর অ্যাজ আ মেশিন লার্নিং ইঞ্জিনিয়ার। data everywhere, that's why machine learning এখন so much in vogue, everyone wants to do it. এটা 2012 সালের স্ট্যাটিস্টিক্স। ইউটিউব users upload 48 hours of new video every minute. Instagram users share 3600 new photos every minute. You can just sense what is happening here. Like every minute, gigabytes of data is being generated. So all this data, and with data comes so much opportunity to learn things. সেটা ছিল 2012 সালে, এখন এটা 2014 সালে। 2014 সালে আরো অবস্থা। এখন 72 ঘন্টা ইউটিউবে 72 ঘন্টা ভিডিও আপলোড হয় পার মিনিট। অ্যামেজিং, চিন্তা করলে জিনিসটা মানে মাইন্ড বগলিং। So these are some examples of machine learning, how you can use machine learning. So already being used by all the big companies. Suppose you have এটা তো সবাই জানি, এটা একটা হিউজ প্রবলেম। মেইল বক্সে স্প্যাম আসে, কিভাবে আইডেন্টিফাই করে কোনটা স্প্যাম কোনটা হ্যাম? They use machine learning. Most typically they use, I think, an algorithm called naive Bayes, because it's a simple algorithm but it works so good. So it takes as input real legit emails and take as also input as spam emails. তখন সে ফিউচারে আইডেন্টিফাই করতে পারে কোন ইমেইলটা কোন টাইপের ইমেইল, স্প্যাম অথবা ভ্যালিড। Then recommendations, of course. All these companies, online companies, they recommend you books. How do they recommend it? They use something called collaborative filtering, and now they use also deep learning techniques. So they recommend you these books based on your purchasing style and all other kinds of factors. Fraud detection ইউজ হয়। এখন তো ক্যাশ মানি অলমোস্ট ইউজ হয় না বললেই চলে, স্পেশালি ওয়েস্টার্ন কান্ট্রিগুলোতে। So all these online transactions, how do they detect fraud detection? They use some kind of machine learning. Any type চ্যাট বক্সে একটু তোমরা লিখলে ভালো হয় যে সবকিছু ঠিকঠাক মতো চলতেছে কিনা, নাহলে আমার পক্ষে বোঝা টাফ। Okay, cool. So all these online transaction companies like PayPal and others are using machine learning to detect fraud. These are some examples of how machine learning is being used in academia in different departments, different fields. So this is a paper actually from Iowa State Mechanical Department থেকে, যেখানে ওরা মেশিন লার্নিং ইউজ করতেছে আর কি কম্বাসশন ইনস্টাবিলিটিস ডিটেকশনের জন্য। ওরা ডিপ কনভলিউশনাল অটো এনকোডার্স লাইক কনভলিউশনাল নিউরাল নেটওয়ার্কস ইউজ করতেছে এই জিনিসটার জন্য, যেটা একটা নতুন ডিপ লার্নিং টেকনিক ফর ইমেজ ক্লাসিফিকেশন। Another cool application in civil engineering, they are trying to predict using neural networks again to create predictive models with the aim of minimizing the usage of scarce resources. So every field basically they are using machine learning in some innovative ways to solve problems, because we have so much data. In some cases data is scarce, but mostly you can find at least some kinds of data set to use. So this is a kind of a cheat sheet for all the machine learning algorithms. This from the scikit-learn website. Scikit-learn is the best available Python machine learning library right now. So you guys should go to that website and check it out. So classification. So ক্লাসিফিকেশনের জন্য কোন টাইপের অ্যালগরিদম গুলো ইউজ করা যেতে পারে। রিগ্রেশন হলো ক্লাসিফিকেশন হলো 2-3টা ক্লাস থাকবে, তুমি ট্রেন করবা, সে প্রেডিক্ট করবে তোমার লেটেস্ট যে ইনপুটটা সেটা কোন ক্লাসে বিলং করে, এটা ক্লাসিফিকেশন। রিগ্রেশন হলো it's like a stock market price prediction, housing price prediction, where you predict a real value as your output. Okay, then you have dimensionality reduction, where you are reducing the dimension of your data set to get your most salient features, I guess. And then you have clustering, which is a kind of unsupervised learning algorithm, যেটাতে তোমার ট্রু লেভেল থাকে না। সাপোজ ক্লাসিফিকেশন তো তুমি যখন ট্রেন করতেছো তখন লেভেল দিয়ে দিচ্ছ। সাপোজ তোমার কাছে ডগস অ্যান্ড ক্যাটস ইমেজ আছে, তুমি যখন ট্রেন করতেছো তখন অ্যালগরিদমকে বলে দিচ্ছ যে এটা ডগ, এটা ক্যাট। ক্লাস্টারিং ইজ আনসুপারভাইজড, যেখানে তুমি জাস্ট ডেটা দিয়ে দিচ্ছ, সে জাস্ট নিজেই প্যাটার্ন খুঁজে বের করার চেষ্টা করতেছে যে এই ইনপুট গুলা, এখানে কোনো ট্রু লেভেল নাই, কারণ তুমি নিজেই লেভেল জানো না। সো সে ক্লাস্টার করার চেষ্টা করতেছে যে এই ইনপুট গুলা একটা ক্লাসে বিলং করে, এইগুলা একটা ক্লাসে বিলং করে। So unsupervised learning is really cool. যদিও রিয়েল লাইফে মোস্টলি সুপারভাইজড লার্নিং ইউজ হয় রিয়েল লাইফের অ্যাপ্লিকেশন গুলায়, বাট ট্রু এআই আসলে যদি কখনো আসতে হয় সেটা আনসুপারভাইজড লার্নিং এর থ্রুতেই আসতে হবে, কারণ লেবেল দিয়ে ট্রু এআই করা সম্ভব না। নাও রিসেন্টলি যেটা ডিপ লার্নিং, দ্য রিভলিউশন ইন এআই উইন্টার চলতেছিল অনেকদিন ধরে, তারপরে আবার ডিপ লার্নিং সেটা এখন সেটাকে আবার দূরে সরাই দিয়ে এআই সামার নিয়ে আসছে। So what is deep learning? Deep learning is a fancy name for neural networks. Neural networks are just where they try to mimic the brain, how the brain works. You have lots of inputs, and all the inputs are connected to hidden layer nodes, and those hidden layers are stacked against each other, and at the end you give it output. So suppose you have তুমি ডগ আর ক্যাটের ইমেজের মধ্যে ক্লাসিফাই করতে চাও, তুমি ইনপুটে ডগ আর ক্যাটের ইমেজ দিবা আর আউটপুটে লেবেল দিবা 0 1, 0 ডগ 1 ক্যাট হলো 1। এইভাবে প্রচুর ইনপুট দিবা আর সে ট্রেন করবে। সো এট দি এন্ড অফ দ্য ট্রেনিং তোমার হিডেন লেয়ার গুলা, মাঝখানে যে হিডেন লেয়ার 1 হিডেন লেয়ার 2 এগুলা তাদের সাথে ওয়েট অ্যাসোসিয়েট করা থাকে, সেই ওয়েট গুলা সে লার্ন করবে। তখন সে ফিউচারে যখন তুমি তাকে নতুন ইনপুট দিবা তখন সে প্রেডিক্ট করবে কিভাবে কি করতেছে। তো ডিপ লার্নিং এর মডার্ন ডিপ লার্নিং এর ফাদার ধরা হয় 3 জনকে বেসিক্যালি। তাদের মধ্যে গড ফাদার একজন আছে, সে হলো জেফ হিন্টন, আগে ইউনিভার্সিটি অফ টরন্টোতে ছিল, এখন উনি মনে হয় পুরো টাইম গুগলে কাজ করে। আর ইয়োশুয়া বেনজিও ইউনিভার্সিটি অফ মন্ট্রিয়ালে, ইয়ান লেকুন নিউ ইয়র্ক ইউনিভার্সিটিতে, সে ফেসবুকের এআই রিসার্চ যেটা সেটারও ডিরেক্টর। Can you tell us a bit more about the layers? Yes, layers are just nodes. I guess তুমি চিন্তা করতে পারো লেয়ার গুলো আসলে বেসিক্যালি লিনিয়ার রিগ্রেশনে তোমার y is equal to ax প্লাস bz প্লাস c, এখানে যেমন প্রত্যেকটা ইয়ার সাথে তোমার ইনপুটের সাথে একটা করে কোএফিসিয়েন্ট তুমি গুণ দিচ্ছ, সেরকম তুমি কোএফিসিয়েন্ট ধরতে পারো এই নোড গুলার যে ওয়েট গুলা, সেই ওয়েট গুলাকে। বাট লিনিয়ার রিগ্রেশনের সাথে একটা ডিফারেন্স হলো এটাতে প্রত্যেকটা নোডের পরে একটা অ্যাক্টিভেশন ফাংশন থাকে। ধরো সিগময়েড বা ট্যান এইচ বা রেলুস, যে অ্যাক্টিভেশন ফাংশনগুলো এইখানে নন লিনিয়ারিটির ইন্ট্রোডিউস করে। সো সাপোজ তোমার একটা নোড আউটপুট দিল 500, কিন্তু সেই নন লিনিয়ারিটির কারণে সে জিনিসটাকে 0 আর 1 এর মধ্যে স্কোয়াশ করতেছে। রেলুর ক্ষেত্রে 0 আর ম্যাক্স যেই ভ্যালুটা সেটার মধ্যে স্কোয়াশ করতেছে। তো এই নন লিনিয়ারিটার জন্ম দেওয়ার কারণে neural networks are so powerful. Neural networks can actually approximate any function in the universe. So there's a mathematical theorem on that that is proved that a sufficiently big neural network can approximate any function in the universe. So ওইখান থেকেই আসলে নিউরাল নেটওয়ার্কের এই পাওয়ারটা আসে, যে তুমি এত কমপ্লেক্স প্রবলেম ওয়ার্ল্ডের, যে এত কমপ্লেক্স ডেটা সেটস, সেই ডেটা সেটের যেই ফাংশনটাকে তুমি আলটিমেটলি প্রেডিক্ট করার চেষ্টা করতেছো, যেটার ইনপুট দিলে আমি এই আউটপুট চাই, সেই ফাংশনটা তে পৌঁছানোর জন্য নিউরাল নেটওয়ার্কস গুলো এই নন লিনিয়ারিটি ইউজ করতেছে। সো দ্যাটস ওয়্যার দেয়ার power actually comes in. I hope that answers your question, or you can ask me later. Okay, you want to know the importance of number of hidden layers. Increasing hidden layers will increase my accuracy or what? Depends on your dataset size. তোমার dataset size যদি huge হয়, definitely increasing hidden layer is a good idea. But at the same time তুমি hidden layer increase করতে পারো, আবার তোমার যে অলরেডি লেয়ার আছে সেই লেয়ারের নোডের সংখ্যাও তুমি ইনক্রিজ করতে পারো। বাট এগুলোকে অ্যাকচুয়ালি বলে হাইপার প্যারামিটারস। সো হাইপার প্যারামিটার টিউনিং নিউরাল নেটওয়ার্কস এর খুবই ইম্পর্টেন্ট একটা জিনিস, খুবই পেইনফুল একটা জিনিস অবশ্যই, কারণ তোমাকে সেই হাইপার প্যারামিটার গুলো টিউন করতে হয়, বারবার অনেক হাইপার প্যারামিটার দিয়ে দেখতে হয় যে কোনটা আসলে বেস্ট কাজ করতেছে। সো এই জিনিসটা খুবই পেইনফুল। সো যখনই তুমি নিউরাল নেটওয়ার্ক ট্রেন করতে যাবা, neural networks are cool, really cool, but once or twice after you are trying to train them, you see that they are very much painful to train. Hyperparameter tuning এর জন্য randomized search use করে বর্তমানে। There are some companies actually that are serving for Bayesian hyperparameter search. You can look at them, search for them. Personally আমি randomized search use করি, আর মোস্টলি এটা আসলে ট্রেন করতে করতে একসময় একটা ইনটুইশন জন্ম নেয় যে কি ইনক্রিজ করলে কি হইতে পারে একটা স্পেসিফিক ডেটা সেটের জন্য। আর যখন তুমি শুরুতে ট্রেন করবা, অফকোর্স তুমি পুরো ডেটা সেটের উপরে ট্রেন করবা না, তুমি একটা সাবসেট নিবা, সেই সাবসেটের উপরে শুরুতে ট্রেন করবা, আর তোমার ভ্যালিডেশন স্কোর দেখবা। ভ্যালিডেশন স্কোর ইমপ্রুভ করতে থাকলে তার মানে ইউ আর অন এ গুড হাইপার প্যারামিটার সেট। So that's it. If you have any more questions, please ask. Okay, এই তিনজন গেল। এই তিনজনের পরে অ্যান্ড্রু ইং আছে স্ট্যানফোর্ডের। অ্যান্ড্রু ইং বেসিক্যালি ডিপ লার্নিং কে ইন্ডাস্ট্রিতে জনপ্রিয় করার পিছনে প্রথম কাজ করে, যেটা হলো উনি যখন গুগল ব্রেইনে ছিলেন তখন উনি মনে হয় 200 আওয়ারের মতো ইউটিউব ভিডিও আই থিঙ্ক ট্রেন করে ক্যাট প্রেডিকশনের জন্য। So that neural network learned how to identify cats in YouTube videos, and that was the first major thing in industry, and everyone was looking at Google at that time, and everyone started to jump into the bandwagon of deep learning after that. And then we have Jürgen Schmid, who is in Switzerland, I think, who has a great lab তার ল্যাব থেকেই অ্যাকচুয়ালি LSTM বেরিয়েছে। LSTM হলো লং শর্ট টার্ম মেমোরি, যেটা হলো ন্যাচারাল ল্যাঙ্গুয়েজ প্রসেসিং এ এখন এভরিওয়্যার LSTM অথবা GRU আর একটা গেটেড রিকারেন্ট ইউনিট, এই দুইটার একটা ইউজ হয়। তো ইউরগেন স্মিডহুবার এর ল্যাব থেকে 1997 সালে সেই LSTM এর পেপারটা বেরিয়েছিল, কিন্তু আলটিমেটলি এটা জনপ্রিয় হলো 2011-র দিকে। উই উইল কাম টু দ্যাট। এই পাঁচজন হলো হিউজ ইন টার্মস অফ ডিপ লার্নিং। There are countless people now who are working. I thought the course was supposed to be in English. Yeah, I didn't say that, but I guess I should have. Okay, I'm sorry about that. I will try to speak in English from now on. Okay. So Jürgen Schmidhuber is from Switzerland, and his lab produced that LSTM paper. And also there are these new kinds of neural networks called generative adversarial networks by Jan Goodfellow. He was a PhD student of Yoshua Bengio. Generative adversarial networks actually are the current state of the art in many of the image processing tasks, and everyone now do research on this. Actually, there's a funny video where in NIPS at one of the conference, Jan Goodfellow is giving a talk on generative adversarial networks, and then Jürgen Schmidhuber actually stands up and argues with him that he also contributed to that line of work. There's a funny Twitter account called Schmidhubert, and everyone, you should follow that on Twitter. So how did this revolution in AI come in? As I said, AI neural networks had a bad time during the 90s. So the earliest work was as early as in the 1950s, I guess, where I forgot the author's name. He introduced the perceptron network, the simplest kind of neural networks. Then during the 80s, the neural networks had a great time. Actually, Jeff Hinton and Jan LeCun, all these guys actually used to work on neural networks at that time. In the 90s, the bad time came, called the AI winter, where neural networks weren't working as good as other techniques, because data sets were not very huge and computational resources were hard to come by. Actually, during the 90s, support vector machines came into vogue, and everyone was doing research on support vector machines and kernel machines and all this stuff. Like everyone now wants to work on deep learning or neural networks. But anyway, so deep learning came back strongly in 2006 with a paper from Jeff Hinton's group, reducing the dimensionality of data with neural networks, where they use one type of architecture called autoencoder to reduce the dimensionality of a huge dataset and extract important features from that dataset. He wrote it with his student, Raslan Salahuddinov. Actually, I was fortunate to meet him at a workshop. So after that paper, everyone wanted to see what deep learning can do, and everyone was jumping on deep learning again. But these guys, these fathers of modern deep learning, these guys persisted with neural networks during the 90s also. They didn't stop, and perseverance pays off, actually. So what changed? Why did neural networks came into vogue again? Because huge datasets. We have huge datasets now, and neural networks learn greatly from these datasets, and we have more computational resources. Training neural networks is a huge pain. And if you want to train it in the CPU, it's almost impossible. You need GPUs, and because we have very proficient GPUs now. They are still slow, but it's miles ahead if you just use the CPU. So after 2006, there came this paper again from the Hinton lab in 2012. The paper is called Basic Difference Between ML and DL. ML is just any kind of algorithm that learns from data. Deep learning is a neural network that learns from data. Deep learning is just neural networks. So there then came this paper called AlexNet in computer vision. So they used to have this competition called ImageNet every year, where ImageNet is a huge data set with 1,000 classes of images with I forgot the exact number, but millions of images, where they want to classify all of them. And it's like the Olympics of computer vision. So every year they arrange this competition and see which algorithms, which team's algorithm can classify the images perfectly. And Alex Krzyzewski, I'm not sure if I'm pronouncing the last name correct. Alex Krzyzewski's paper with Jeff Hinton, they used convolutional neural networks, and it performed with an error rate of 15.4%. And the next best algorithm was 26.2%. So a 10% increase in accuracy is huge. It's like huge in computer vision. And then again, and through this paper, deep learning, like it came to the masses. Like everyone is looking at deep learning again on why this works so much better. There is recently Google Net in 2015 won this competition, and then Microsoft ResNet won it in 2016, and they reduced the error rate to 3.6%. In 2017, 2016, no, 2017, yes, 2017. 2017, this year was the last time ImageNet competition was held, because they almost reduced it down to 1%, I think. This year's competition was won by an algorithm, an ensemble algorithm, where they used lots of neural networks, I think. I'm not sure, because I didn't follow after 2016. So these are some of the cool applications of deep learning and how they are impacting us in every way. So object detection, as I showed earlier, deep learning is used. It's the de facto convolutional neural networks is the de facto algorithm for now in object detection. Then you have caption generation, where you give the algorithm an image, and it generates a text of what it is understanding from that image. They are using a convolutional neural network as well as a recurrent neural network on this. This work is actually done by Andrej Karpathy from Stanford, who is now the director of research at Tesla, I think. I also met him in a workshop, so he's a very nice guy. These are really cool, right? You give an image, man in blue wetsuit is surfing on wave, like, yeah. So then another application is image colorization. You give it a black and white image, it colorizes the image. So you can actually colorize lots of black and white images from the past, like in the 1900s. So this is an application where sound, you can add sound to muted videos. I haven't really watched the video. Let's see if it works.
Materials make distinctive sound.
Can you hear the sound of the video?
These sounds can tell us how objects behave when we physically interact. They can convey whether an object is hard or soft, smooth or rough, and rigid or deformed. In this work, we consider the material understanding task of predicting what sounds will.
Can you guys hear the sound of the video?
To perform this task well, the algorithm has to recognize the materials that are being hit and the actions that are being performed, but we don't tell Instead, it has to learn about them by recognizing the patterns in raw audio. Our algorithm takes a video and it predicts a corresponding sequence of sound features. Then it generates a waveform. We get these sound features by training a recurrent neural network to regress cochleogram features in each video. This is a simple sound representation we obtained by decomposing the audio waveform into frequency channels with a bank of bandpass filters.
I turned up the video.
To represent the video frames, we use a convolutional network.
Oops, sorry about that.
Materials make Our algorithm can get confused when the motion of the drumstick resembles a hit, but it does not actually strike a surface. Our algorithm also sometimes misses hits, especially when the drumstick is held in an unusual position relative to the camera. Instead of synthesizing a waveform by transferring sounds from a database, we can directly invert the sound features with a simple parametric synthesis method. This can help us understand what information is contained in the sound features that our model predicted. In the paper, we analyzed our model in several ways. First, we asked how well the algorithm could predict plausible sounds. To answer this question, we conducted a human study where we asked people to distinguish real impact sounds from sounds that were synthesized by our model. For this, we trained a variation of our model that predicted sound for individual drumstick impacts rather than for full videos. We found that our sound predictions fooled participants more often than those of baseline methods, including simple image matching models. Next, we asked what the algorithm learned about materials. To study this, we collected a database of semantic labels from human annotators. Then, using these semantic labels, we classified the sound features predicted by the model. We measured how often they had the correct label. Please see our paper for more details.
Really cool, huh? There are lots of interesting problems still to be solved, and you guys can do it. Okay, then we have the example of neural machine translation. Just a minute, guys. Neural machine translation is this is a model. It's called the paper is called actually seek-to-seek models, where you use these LSTM encoders and decoders to translate between two languages. And Google is actually using this now in Google Translator. And I have posted a video here. So that paper was by Quoc Le, who works in Google Brain. And he uses, he published that paper. He was an author on that paper. And you can actually watch this tutorial. I was actually at that tutorial live. He's a very funny guy. So then there's this application of text generation where you use recurrent neural networks. You give it a huge volume of text, and it generates new any type of poetry or literature. So at the left-hand side, you have Shakespeare generated by a recurrent neural network. This is done by actually Andrej Karpathy. You can check Andrej Karpathy's blog. He's a brilliant writer. You should read all his research blogs. And the right-hand side, I generated actually this with all Rabindranath's poems. Check to see if you can find a difference with the real ones. Then we have applications in, of course, bioinformatics, where I work, and I love to apply new techniques in biological problems. Here is a sample paper where they are using autoencoders, denoising autoencoders, to automatically retrieve features from genome-wide assays of breast cancer. So these So they are basically extracting important features from microarray values, and then using those features, they can predict in future if someone has breast cancer or not. So all these applications and stuff. So how to start learning machine learning? Okay, in my opinion, these are all my opinions, so you are free to disagree. In my opinion, the best intro to machine learning is through the Coursera course by Dr. Andrew Ng. I started my machine learning journey with that course when I was at the end of my third year at IoT. I did that course. I was one of the students of that course, and that course actually started Coursera. So this is the best available course, very accessible. He waters down a lot of the difficult mathematics. And if you learn well from books, then these are two of the best books I have seen anywhere. Python Machine Learning by Sebastian Raschka, or Hands-on Machine Learning by Aurélien Guéron. Both are very good. I learned from both of them. How to start learning deep learning? The best course for deep learning, books are not really the best way at the moment. There are very few good books. So how much programming background? Okay, I'm coming. Programming background and general maths background is required to start ML. Okay, I'm coming to that. The best course for intro to deep learning at the moment is the fast.ai course on deep learning. It just assumes you know programming and nothing else. And that is what my preferred approach to for anyone beginning in deep learning or machine learning. You definitely need mathematics if you want to do research in mathematics, in ML or DL. But if you don't know the necessary mathematics, that shouldn't prevent you from entering this field. You just need to know programming. And this course assumes you just know programming, and you pick up the mathematics as you go along with the course, and they are introducing new concepts. Deep learning for deep learning for computer vision, Stanford CS231N course is hands down the best. This course was originally developed by Andrej Karpathy, a brilliant teacher. For natural language processing, again, Stanford CS224N. I learned a lot from it because bioinformatics and natural language processing both works with text data, and a lot of the techniques overlap between these two fields. I actually try to implement lots of NLP techniques in bioinformatics to solve biological problems. This course was developed by Richard Socher, who is also a very good teacher, actually. So my message is don't be afraid of the math. Yes, there is heavy math involved, but not at the beginning. And you can pick up that math as you are going along. If you are mostly applying ML or DL, you don't need to be as good in the mathematics side or what is going on under the hood. If you are just on the application side, it always helps to know what goes under the hood, because then you can debug your algorithms. But you can pick it up as you go along, as I do. I picked up the math as I went along. But you definitely need to know programming. And if you know Python, then that's great, because all of the deep learning community, they either work with Python, or they work with a library called Torch. Torch's language is Lua, but that's a very small percentage. If you know Python, that is great, because I suggest you to start deep learning with using Keras. Keras is a very high-level library, and you just call the functions, and you just have to know the API basically, and nothing else. Then you can go on to our framework that works with that works on a much lower level. If you love math and you feel ready to get into the theory, then the best book, there's just only one book that is the best at the moment, and that is Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Courville. This book is hands down the best available book at the moment, but it is very dense and it is very heavy on theory, and it has no code, but it has practical tips for applying deep learning into real world. You should definitely look at it. It's online and it's available for free. How to start research? For research, you have to read the literature. Following the literature in deep learning or machine learning can be very taxing, because this field doesn't wait for any kind of journal or any conference at all. They just do a thing and post it on arXiv. Every day there's like 5 or 6 new important papers, and you have to read those. But I suggest, to get into the literature, you read the previous NIPS conference or ICML conference proceedings. These are the 2 main important conferences in this field. In this field, publishing in these 2 conferences are the most important and most valuable. They don't really give importance to journals anymore, because it takes time to publish in journal, and they are the current state of the research is such that they are beating state of the art every week. So this week a paper comes in and beat a previous state of the art, and the next week then there's another. And so read first from these 2 conference proceedings, their previous papers, and follow arXiv. And for computational biology, if you are interested in computational biology, you should definitely keep check with bioRxiv. bioRxiv is where people from computational biology post their preprints. And also to always get yourself acquainted with what is going on in this research. You should have a Twitter account, because all these researchers are in Twitter. You can actually follow me on Twitter and go to and notice the people who I follow, and follow those people, because nothing beats Twitter. Everyone is posting on Twitter the latest research, the latest important research, and what is going on these days. So Twitter is the best place to keep yourself knowledgeable on the latest research. So questions. I will now switch from this. Okay. Okay, it's question time. You guys have any questions? I will post the Google Slides link on Facebook after the session. Yes, you definitely need GPUs to train your neural network, but I think a low-cost GPU will be enough to start learning. A low-cost GPU would be like NVIDIA's 1060 now. NVIDIA 1060 value. GTX 1060, I guess it's a good option to get into. It's $300 in US dollars, so it would be, I guess, well, it's not only actually, so 20,000, I guess, at least 20,000 taka. Yeah. You have lower, actually low cost options than 1060. Okay, I will try to find. There are good blogs on what GPU is best to get into deep learning, I will post a link here, hopefully, inshallah. GPUs are needed because there are lots of matrix multiplications in deep learning, and CPUs cannot do it in a fast way. GPUs can do it. Actually, that's why they use GPUs in video game, because you have lots of matrix multiplications in video game animation. Of course, there is always the need for pre-processing in any kind of data set before you train them. It depends on your data set, but yeah, always. In many cases, pre-processing is more important than the training itself, because basically, if you give garbage to a training algorithm, it will output garbage. So your input has to make sense to the algorithm as well. You have to standardize the features, many times normalize them. It depends on your data set. Would programming knowledge equivalent to that 6.00x of MITx at x2? Yes, it will do. An intro to programming class will be sufficient, given that you are enthusiastic. Yes, there are Amazon AWS services where you can use their GPUs to train your algorithms. Amazon AWS, yeah, Amazon Web Services. Actually, the course I mentioned, the deep learning course from fast.ai, they will show you how to train your algorithms on Amazon AWS. So you don't need to buy, actually. But if you buy locally, it's more convenient to train your algorithms. Any knowledge of application of MLDL in any Tripoli specific field? Tripoli.
Robotics, autonomous.
Yeah, autonomous driving. Yeah, autonomous driving, yeah. Self-driving cars. Actually, many people from EE actually work on these problems, these object detection and other problems that I showed you. Self-driving cars are the current hot problem. There's a lawsuit actually going on between Uber and Waymo, which is owned by Google. Google is alleging that Uber stole their self-driving technology. Just search for machine learning for EE problems. I'm sure there are many problems that you can use MLDL to apply to EE. Because the problems that I showed you from mechanical engineering or civil engineering, I actually just Google searched for them. How to know which layers are needed to extract any specific feature? Actually, for extracting features, you use an architecture called autoencoders. In autoencoders, usually you have just one layer, one hidden layer, and you take that layer. But you can also use stacked autoencoders that have lots of hidden layers. But at the end, you just take the middle layer of those hidden layers. There's also this cool paper by Matthew Zeller from New York University, I think, where he shows how a convolutional neural network actually extracts features gradually. So if you give the network lots of images, first it looks at low-level features, and then it kind of merges them into high-level features, and it at the end you get very high-level features that are almost like it's like human-level image recognition. It's called you should read that paper. It's called, I think, Visualizing Convolutional Neural Networks by Matthew Zeller. Can we apply MLDL to solve some healthcare diseases or predict any solutions through computer? Yeah, sure. The deep learning is being used to detect skin cancer, and they have actually compared it against human doctors, and actually the algorithm beat human doctors in predicting skin cancer. That research is from Stanford Medicine School, actually. Just search for skin cancer detection, Stanford. You should get that paper. They are using deep learning for all kinds of cancer detection. In biology, there's also this thing called alternative splicing that happens with human beings. They also use deep learning to detect alternative splicing. Actually, lots of startups are in Silicon Valley. They are trying to use deep learning to solve healthcare problems. Any more questions? Can we hijack this session from MLDL and turn it into a generic higher study question answer session? Sure, go ahead. Do you want to say hello? I have Mehran here from MC08. He's from mechanical, but he is working as a software engineer now at John Deere. Can deep learning be used in search engines? Why not? If you have lots of text data, you can use it for search engines. But I don't know. Maybe Google already uses deep learning for search engine. Who knows? So anytime you have lots of data, you should think of deep learning. But that doesn't mean that if you have less data, you cannot use deep learning. Okay, so it's a bit of an intuition. You have to try. That's what I would say, to see if neural networks are working good with a small data set. Like try to do cross-validation to see if the validation performance is good, or if the neural network is overfitting, meaning it's working good on the training data set, but not working good on the test data set. Actually, there are examples where neural networks are really good in a small data set too. What are some good universities for data science, ML, DL? I guess these days, all top-ranked computer science schools are good because they are all working with ML, DL. But if you want to specifically go for deep learning or ML research, like research in ML or DL, not any kind of applications, then of course the top schools are Stanford, Carnegie Mellon, University of Toronto, New York University, University of Montreal, California, Berkeley, MIT, though MIT kind of, it seems, got a little bit behind in this kinds of research. Stanford and CMU and Berkeley are the top of the bunch. But it's really hard because everyone wants to get into those labs, especially University of Montreal, where Yoshua Bengio is. That lab, everyone wants to get in there. University of Alberta is also good for AI. Other than that, it's all the good universities, generally, depending on which side you want to apply these techniques for. For bioinformatics, I would suggest to go into specific bioinformatics programs, not into computer science programs that do also do bioinformatics research, but go into there are many good departments that are just doing bioinformatics research. Department of Bioinformatics or Program of Bioinformatics. But there are also computer science departments that are doing really good research in bioinformatics. But to get into go into a dedicated program or department is good because you have lots of options. What is the future of AI in the US worldwide? From what I'm reading in USA newspapers, many people are gonna lose their jobs due to AI. So what does the job market in USA look like from your point of view? It really doesn't matter because people are losing already jobs to automation all the time.
Yeah.
So you just have to find
You have to learn new skills.
Yeah, you just have to find new kind of employments. And also as a computer scientist, mostly most computer science students work as software engineers, but in near future, every software engineer now has to have a good grasp on data structures and algorithms. That's a given, right? To work in any good company. But I think in near future, you also have to know basic machine learning. And that will be a given. That has to be a given, yeah, because machine learning and deep learning will cover everything. Yeah, countries like BD will be hit hard. They won't even know what hit them. No, I'm serious. Any more questions? Yeah, do lots of projects and put them on GitHub. That will help you get good jobs into good schools. Like as you are asking about these schools which are good, you won't get into them if you don't have lots of projects on your GitHub. Lots of projects, and you start writing a blog on them after you do a project. That will really help. Without projects, you won't get into any good school.
Good thing is you can do this at your own, right?
Yeah,
if you
yeah,
do good
yeah.
computer, good machine, you can do it.
Yeah, that's what it's good about computer science. You can just stay at your home and do projects. Just buy a GPU and start doing projects. It's really easy to get into DL because there are so lots of resources online. You just have to find them. You just have to be enthusiastic.
And lots of problems, even local problems.
Lots of local problems. Yeah, you can just make an app. You can easily make an app within like 3 or 4 days that will solve some kind of problem. Any kind of small projects going on. Any websites, projects. As I have given you the resources on that, on those courses, right? CS 229 for computer vision, CS 224D for NLP. Go to that website and they have projects of students from previous years. Go through them and check out what they did. You will generate new ideas from that. Students really do cool works in those courses. So these are generic tools, actually. Once you learn them, you can apply them throughout any field. You are not compartmentalized in a single field. Okay, generic tools can apply to any field. As I showed you, people from the mechanical engineering department applied these techniques to solve mechanical engineering problems. And stay on Twitter, actually. If you want to go into academia, stay on Twitter, like for higher studies. You will know what is happening right at the moment.
You can follow some good labs from.
Yeah. All the professors and all the all the graduate students are on Twitter. Any more questions? I don't know. Shut up. Yep. আসসালামু আলাইকুম, কি অবস্থা? তুই তো পুরো শুকায় গেছিস। কথা বলতে হবে একদিন। Hi, are there any major drawbacks of DLML? Drawbacks, yes, of course there are drawbacks. There is a theorem called no free lunch theorem. It says that no algorithm is good for all kinds of problems. Okay? So every algorithm has pros and cons. So what are the major drawbacks of DL? I guess you cannot work with very small data. It will overfit. Neural networks will overfit with very small data. Another problem is, I guess everyone speaks about, is interpretability. For example, linear regression or other kinds of algorithms, you can interpret them with the associated coefficients. The coefficients will denote how much importance it is assigning to a certain feature, right? For neural networks, that is one of the problems. Like, how is it generating a certain output? What are the important features? So, for example, in lung cancer detection or skin cancer detection, which features are contributing to that detection of a neural network? that is kind of difficult. I guess it's not impossible, because there are lots of good work on interpretability of neural networks now, where they are trying to like go from the input back towards the go from the output back towards the input, and they are trying to get those activation derivations to see which feature is contributing more towards the output. So interpretability is definitely a bottleneck, but there are good work going on now on that. Actually, I myself am working on interpretability for in bioinformatics. Having said that, you shouldn't be afraid of using deep learning in a small data set. You should definitely try it and cross-validate to see if it is working good there. Okay. I always try it.
What is the difference between big data and machine learning?
Big data is kind of very vague word. No one knows like what is big data, but everyone is working on it. It's supposed to be like whenever you have a huge data set, but then there's a controversy on what is a big data set. Is it gigabyte, terabyte, or petabyte? There are lots of big data frameworks that are mostly used in industry, I guess.
Say, NSA, they store metadata on our voice calls, internet usage, and everything. What kind of machine learning algorithms do they use to find potential terrorism? Do you have any idea or something like that?
How will I know what is NSA doing? NSA is perhaps listening to this broadcast right now. Hi guys. Yeah, but that's a good question actually. I don't know what. I guess they have massive data set. If I have that size data set, I would definitely try neural networks. But neural networks inherently works good on data that have an inherent structure in themselves, like image data or natural language data or nucleotide sequences or protein sequences that have an inherent structure within themselves. If you have like just features, so for example, you are trying to do house prediction, house value prediction. So there you don't have like that kind of structured data. There you have features, like these have these many bedrooms, these many bathrooms, this size of yard. In those types of things, neural network can still do good, but I would say other general machine learning algorithms will match with the neural network in performance.
Transportation system.
Hi Topo. Yes. Let's catch up soon, inshallah.
In transportation systems.
Transportation systems?
Yeah, there is a lot of data on traffic and everything. What type of technology people are researching? Is it neural networks? What do they? I don't know. Big data or machine learning or whatever. I don't know what they're using, but I know there are a lot of researches going on in intelligent transport system, IDS they call it, and
yeah,
some people who work on it.
Yeah, machine learning is being used everywhere. Like I have a brother here who's in the geology department. He's predicting some geological information using machine learning, and they have neural networks already applied to those geological predictions actually. Can you tell us a bit about your work? I mean, in simpler terms. Yes, I actually work in bacteriocin prediction. So bacteriocins are toxins produced by bacteria. They use to kill other bacteria in their system. in a so why do they want to kill other bacteria? To survive, I guess. Actually, you can use those toxins to create new antibiotics. So antibiotics resistance is a huge problem now these days. So yeah, so the good thing about these bacteriocins is they are narrow spectrum toxins, meaning if you they target them, they use them to target only certain bacteria. So if you apply those toxins, they will kill only certain bacteria, not other bacteria, because there are bacteria in your body that are needed for your good health. So I try to find those bacteriocins from amino acid sequences so that they can be a good candidate for future antibiotic production. Actually, I have a very small label data set, very small, so I cannot really use neural network on that. So that's why I use unsupervised deep learning to learn from unlabeled data. So there are huge unlabeled data sets in bioinformatics available. If you can learn somehow from them and then use that unlabeled data set to extract features and then try to apply that to a super small data set problem. Actually, my paper work on this recently got accepted at ICML's computational biology workshop. So ICML has a main track where research on just in machine learning and deep learning, and then they have individual workshops on these applications of ML or DL in individual fields. So they have a computational biology workshop. You can, if you are interested in computational biology, you should definitely check out the workshop for ICML, and also there is a computational biology workshop for NIPS too. Lots of interesting applications of MLDL in computational biology. Any more questions? It's 12:22 here, 11:22 at BD. So I will take questions till 11:30. So 8 more minutes. If you guys have any questions. Yeah, sure. I will provide a link. It is being recorded.
Bottom line, do this like Stanford reports the
yeah, I provided them with the links. Yeah,
start somewhere.
Yeah, I actually started at 3rd year, so
it's never too late.
Yeah, and it's never too late in anything in life. So an ITN brother actually posted that link of that Andrew Ng class, and I saw that when I was at the end of IoT 3rd year. My CG was really bad at that time. I did that course. I really got inspired, and I thought I would like to do higher study on this. So I need to make up for my poor CG. So I was more serious in my 4th year. That Andrew Ng course was really inspirational. I actually met Andrew Ng recently at a workshop, and I told him that.
That's the big thing. Like meeting your academic hero, some sort of. Right?
Yeah. At 11:24. Any more questions? Coursera, just search for Coursera machine learning and reviewing. You will get it.
Everywhere.
Yeah.
I even started.
Yeah, my suggestion is just jump on it and start coding. Okay, and you will get the understanding later by coding. If you can code it yourself, you will get what you are doing. So that's why the deep learning course from fast.ai is so good, because you are all the time you are implementing something. So whenever personally I try to learn a concept, first I don't go to the math. I try to code it from somewhere. If I can code it, I get almost all the thing. Then I can look at the math actually. It gives you a broad level overview first. You need basic linear algebra and calculus after that, but you can pick it up after that. So at the beginning, you just need to know programming. And people from any department. That's why people from any department can jump in anytime. And here, there are actually no departmental barriers. Everyone works on everything. Like in Iowa State, most of the deep learning work actually comes from the mechanical engineering and the industrial production department, not from the CS department. How to be very good at programming? Can you tell what to do at the beginning? Just do lots of projects. You can do Coursera courses actually. Coursera has a Python course from Rice University. Actually, that's what I completed to learn Python. So that course is very good, where they build 6 small games, and you learn programming. And in the way, you also learn Python. Learning Python is definitely not a bottleneck. Its syntax is almost like writing English. So if you already know programming in another language like C or C++, which I guess is taught at UT in the first year, learning Python is a breeze. You need at most 7 days to learn Python. So after you learn programming, you do lots of projects. And even if you don't do SEM programming, just solve lots of problems. It helps you. So I solved lots of SEM problems at the end of my 2nd year. And it really helped to think about the logic.
Practice.
Yeah, practice. It helps. Also, there's project euler.net, where you solve math problems through programming. That's also good. Other than that, you can also solve problems in, I guess, in websites like Codeforces. Codeforces also has solutions that you can see. from previous competitions. So even if you don't want to be a top, don't want to do competitive programming regularly, it helps you. It helps you to think logically, and those skills actually they are very ubiquitous. So they go into every kind of other work that you will do in future, because logical thinking is a very
It's like the basic thing
yeah.
of engineering. So whatever you do.
Yeah, logical thinking helps in every kind of problem you're trying to solve. So when you are first learning programming, don't really bother much about the syntax. That's why I suggest everyone to learn programming with Python. So you don't have to waste your mental ability on the syntax, which you have to do if you learn programming with C. You can go to lower level later. Just learn things at a higher level first. Okay, it's 11:31 now, so I am ending the discussion for today. If you guys have any more questions, you can just message me on Facebook, or you can also post at the higher study group.
I think that would be better, so that the same question would not be repeated. So
yeah.
do it in the public forum.
Yeah, do it in
Other people would benefit.
Definitely, yeah. Other people will benefit from if you post the questions on higher study group. Okay, so yeah, sure. Thanks. You are welcome. Okay, assalamu alaikum, everyone.